Hi there, this is Math 7, Unit 6, Lesson 10, called Different Options for Solving One Equation. And so we're going to talk today really about the different ways we can go about solving equations with parentheses. And essentially what we're looking at today is that there are two different ways to go about doing this, right? Essentially. There's probably some other ones, but for our conversation purposes, one way we can do things when talking about parentheses is to divide each side by the number that's on the outside of the parentheses. That's one way of doing it. The other way we could solve things is by first using the distributive method. So distribute, and then solve for both sides. So there are a couple ways we can go about approaching a problem. And so when we look at these first ones here, what you're doing in class today is your teacher put up one at a time and gave you a little bit of time to think about how would you go about solving that equation there. And you could do it one of these two ways depending upon what you see and how complicated the computation might be. So let's take this first one just as an example. If I had 100 times x minus 3 equals 1,000, I could either divide both sides by 100 to eliminate the 100 on this side, or I can distribute that out and then solve. In this case, for me, when I look at this, I recognize that I have a nice even number here. I have it as a multiple of 10. I have a bunch of zeros. This has zeros. I can recognize this is pretty easy to divide. If I divide by 100, that goes away. So on this left side, I'm left with just x minus 3. But over here, if I divide by 100, then I can reduce this down to 10 over 1, which is 10. That's not a tough division problem. It doesn't require a calculator or doing long division. I can solve that pretty quickly. So this seems to me to be one of the faster ways to solve this problem. I could distribute, but it might take a tad bit longer. And if I finish that out, if I added 3 to both sides, I'd have x equals 13, and I've solved that there. So in this case here, I don't necessarily need to distribute, but I could. And if I did distribute, I'd have something that looks something like this. I'd have 100 times x minus 3 equals 1,000. So if I distribute that out, I end up with 100x minus 300 equals 1,000. I'd add 300 to both sides, right, like so. So I have 100x equals 1,300, and then I divide both sides by 100 to end up with, cross those out, x equals 13. It's the same solution, I just arrived at it in a little different manner. And so the idea today is to take a look at how you might go about solving questions like these to figure out how to find a solution and what's maybe the easiest way to get there. Let me show you just one more to make sure, if you didn't look at this in class, this one right here. I like this one because it's dealing with a fraction, and when you have a fraction, it's a little more fun sometimes. Here we have 1/7 times the quantity x plus 2 equals 10 over 7. Now in this case here, I'm going to multiply both sides by the reciprocal. If this is 1 over 7, I'm going to multiply by 7 over 1 to both sides. So this becomes 7 over 7, which cancels out to be 1. So the left is left with x plus 2 equals whatever this is. Now the 7 and the 7 will reduce, and I'm left with just the 10. So this was one where it's again good to go ahead and get this part out of the way. And it's like I'm dividing by 1/7, but 10/7 divided by 1/7 is the same as multiplying by the reciprocal, and so you still end up with 10 as a solution there. And again, if I subtract 2 from both sides, I have x equals 8 as my solution. So just remember that you multiplied by that reciprocal there in order to clear that fraction out of the way. Let's take a look at the next activity. In our next activity, we're analyzing different solution methods. And this is a very important skill to look for the precision and accuracy of a student's work, to see where did they go right or where did they go wrong. And so here we have 3 different people. We have Noah, Elena, and Andre, and their method for solving the same equation. When you just kind of quickly look at their solutions, you notice they each have a different solution. You have 19 over 2, -4, and 14, all for the same equation. So either somebody's right and the others are wrong, or they're all wrong. It's hard to say, but they can't all be right, that's for sure. So let's take a look and see what they're doing. For Noah, we see that he begins with 2 times x minus 9 equals 10, and then we can see he's adding 9 to both sides. Now in terms of an equation keeping things balanced, there's nothing wrong with adding 9 to both sides. You could add 5, you could multiply by 7 to both sides. As long as you're to both sides, that's okay. But where does it go wrong? When we take a look at this piece here, by adding 9 to that, do you end up with 2x? That's the question. We know that 10 plus 9 is 19, but is 2 times x minus 9 plus 9 equal to 2x? In this case here, if you think about this, this is 2 times x minus 9 plus 9. That doesn't just make the 9's go away, because you have to do what? You have to distribute that 2 first. And in doing so, you have 2x minus 18 plus 9, and that becomes 2x minus 9. So this is what ends up being on this side of the equation, not the 2x. And so that was a mistake there, because this combined does not equal 2x. It actually equals something a little different. So that's where his error was. Let's check out Elena's method. Now Elena keeps that and she applies the distributive property. Okay, so she went 2 times x is 2x and 2 times negative 9 is negative 18. That's good. So we're in a good place so far. That looks good. And then let's see, what does she do? Then she subtracts negative 18 from both sides. Again, as long as it's done to both sides, nothing is inherently wrong with that. That's okay. But let's see, 10 minus 18 is negative 8. That's good there. But what about this? Is negative 18 and another negative 18, does that go away? Because you can see she only has a 2x there. So what happened to this? Negative 18 minus an 18 is a negative 36. So in reality, what should be right here is 2x minus 36. Elena just kept the 2x and thinking that would go away. So what should she have done there? Well, probably what she should have done would have been to add 18. So instead of subtracting, if she had added 18 to both sides, that would have eliminated that and we would have gotten to a better situation. It's probably what she should have done there. Let's take a look at Andre's method. All right, so he does the distributive property first, 2x, and it gets 2x, and 2 times negative 9 is negative 18, so we're good there. We can see that he adds 18 to both sides, all right, which will eliminate the 18s to give you just a 2x, and 10 plus 18 is 28. That looks good. And then we're going to divide both sides by 2, divide by 2, divide by 2, which clears the variable, makes it just an x by itself, and 28 divided by 2 is 14. So that's okay. Everything is done in the right order, everything is done to both sides evenly, and he doesn't have any careless computational errors. So Andre's method is the correct method and ends up with the correct solution as well. So we would definitely agree with Andre and how he did that there. Our next section is called Solution Pathways. And so for each equation, we want to try to solve the equation using each method, whether that's going to be dividing each side first or applying the distributive property first. We want to try to do both ones. The point of this activity really is to recognize that some equations are easier to solve by one method than the other. And so in this activity, what your teachers are wanting to do is to try it both ways so you can get used to figuring out which way works the best for you. And some of that is just by starting to recognize what's going to happen with numbers when you distribute or divide or multiply to make the computation a little bit nicer. So in this first one here, what I see is I have 2,000 and 6,000. I recognize, again, like our first problem today, these are numbers that have a lot of zeros in them and they're even with a 6 and a 2. This seems to be a good one just to divide both sides by 2,000. Because in doing so, I know that this is going to be eliminated, which leaves me an x minus 0.03 on this side. And in this case, I can eliminate the zeros and the zeros, and I have 6 over 2, and 6 divided by 2 is equal to 3, and that's a pretty easy number to work with, isn't it? So now I can add 0.03 to both sides, 0.03, and so that x equals 3.03, all right? And so that's not too bad there. Could I have done it the other way? Sure, and that's what the activity wants you to do today, which is to multiply that out. So you'd end up with 2000x minus 2 times 0.3. Well, again, that's going to be a little bit more work there. I'm going to have to do, off to the side, maybe 2000 times 0.03, and I get 0.006, moving that over 2 spaces for the decimal, so I'm at 60. And that equals 6,000. Okay, so already I know it's taking me a little more work there to do this so far. I could add 60 to both sides, add 60, so I have 2000x equals 6,060, and then I divide everything by 2,000 to find out what x is going to equal. Now I'll end up in the same spot. 6,060 divided by 2,000 is still equal to 3.03, but that's going to be a tougher computation problem just to do, right? I'm probably not going to want to work that out to get that solution. This was far more direct and got me the answer I wanted. So this would be the easier way than that one. They both work, and so part of working with these problems is trying to figure out which method is probably the one you want to utilize. Let's look at number 2 real quick. In this one here, this is one where I could divide by 2. I could certainly do that like last time, but what I notice is that I have a 2 here and a 3.5. Now 3.5 is not a number that I know really much about, and it's 3.5, but 3.5 divided by 2, I just don't know what that is off the top of my head. So I may not want to divide that by 2 because I'm just going to have to leave it like 3.5 over 2 for now. I don't know. So what I'd rather do in this one is distribute, so that I have 2x plus 2 times 1.25 is actually equal to 2.5. Now I like so far how these numbers are coming out because I can subtract a 2.5 from both sides, and in doing that I have 2x equals 3.5 minus 2.5 equals 1. I like 1. Divide both sides by 2 so that x equals a half. Now that's pretty easy to see there. If I had done the other way, I might end up with I'd end up with the same answer, but it'd be a little more complicated, wouldn't it? Okay, so again, you could do that the other way and see what you come up with. For this one, if I'm solving this one here, I want to clear that fraction out of the way, so I'm going to multiply both sides by the reciprocal. So I have a 1/4 times 4 plus x equals 4/3. I'm going to multiply both sides by the reciprocal, so 4 over 1, so this goes away, right? And I have 4 plus x on this side equals, in this case here, 16 over 3. Now, 16 over 3, I can rewrite that as a mixed number. 3 goes in there 5 times, and I'm left with 1, so 5 and 1/3. So 4 plus x equals 5 and 1/3. I could subtract a 4 and be left with x equals 1 and 1/3. And so that works out just fine. Could I distribute? I sure could. I could distribute that one out. And if I did, I'd have 1/4 times 4 plus x equals 4/3. Oops. Multiplying that, you have 1 plus, multiply that, 1/4 x equals 4/3. If I subtract 1 from both sides, I again have 1/4 x equals 1/3. And it's still multiplying by the reciprocal. You still end up with x equals 4/3, which is the same as 1 and 1/3. So which way is easier? Hard to say in this one. It's fractions, so it depends on what you want to work with here. This one might be the easier way, but it's really what works for you in terms of computation, what you enjoy doing a little bit more. Okay? Now the same is going to be true for number 4 and number 5, and so you can go ahead and solve those on your own and figure out which way you want to go ahead and solve those doing. For this one here, I think for me, I would go ahead and distribute so that I can get rid of that decimal. For 10 times a decimal number, I can get that to be a regular, good old 17. On this one here, I would probably, in this case, I would probably divide both sides by 0.3 on this one so that I can take that and have 5.4 divided by 0.3 equal to a nice number like 18. Just works out a little nicer there. So when I distribute here, I have negative 10x, and this becomes a plus 17, so no more decimals, equals negative 3, and this becomes 18 equals x plus 8. And I can solve those out there. So for me, I just like it that way because I got rid of the decimal, I got rid of the decimals, and it worked out nicely. All right, so that really was today's lesson in class today. And our point here is that, here it is in our summary, that equations can be solved in many ways. So there are lots of ways to solve an equation. The thing is, as you get better at it and practice it more, you find out faster ways to solve them and some shortcuts and some easier ways to manipulate the problem so that your computation is a little less cumbersome. So let's pause there and let you have some time to do your homework, and then we're going to check our homework together. Alright, so here's the homework for Math 7, Unit 6, Lesson 10. So the first one is a review from Unit 4, and we have Andre wants to buy a backpack. The normal price is $40. He knows that a store sells a backpack, is having a 30% off sale. So what's the sales price of the backpack? So to solve this here, we know he's going to take 30% off the sales at the normal price. The normal price is 1 times $40, and we're going to take away 30% of that, so we make 30% into a decimal, 0.30 times $40, and that's going to be our sales price. Call that X for now. I can then rearrange this to make this 1 minus 0.30 times our $40 equals X, and 1 minus 0.3 is 0.70, or 70% times 40 equals X, and 0.7 times 40 is going to be equal to 28. So in terms of the price, the sales price of the backpack, it's going to be $28. This is essentially 70% of the original. And that's what we solved here. 70% of means times the original price to get $28. So remember, 30% off means I do 100 minus 30 to the actual sales price is going to be 70% of the original price. And so that's what we did with this part here, just kind of reviewing from before how we solved that. Again, a couple different ways to get there, up to what you wanted to work on. Number 2. On the first math exam, 16 students received an A grade. On the second math exam, 12 students received an A grade. What was the percentage decrease? Well, decrease is going to be 16 minus 12, which is equal to 4. That's our decrease. And as a percentage of the original, it's 4 divided by what we started with, 16. And 4 divided by 16 is equal to 1/4. And as a decimal, that's 0.25, and as a percentage, that becomes 25%. Moving that over 2 spots there. And that's our percent decrease. Number 3, we have some equations to solve, and this goes with today's lesson here. So let's start with the first one. We have 2 times x minus 3 equals 14. For this one, I'm going to divide both sides by 2. So I have x minus 3 equals 7. I'll add 3, and x equals 10. So for number A, we say it's 10. For B, we have negative 5 times x minus 1 equals 40. Because I know that 5 times 8 becomes 40, I'm going to go ahead and divide both sides by negative 5 so that I can get this by itself. So x minus 1 is equal to 40 minus 5. 40 divided by 5 is a negative 8. If I add 1 to both sides, x is going to equal negative 7. So I did that because I know that 40 divided by negative 5 is a nice easy number to solve. The next one, let's put negative 7 there. Next one, I have 12 times x plus 10 equals 24. Again, 12 and 24, those go together nicely, so I'm going to divide both sides by 12. And we'd say x plus 10 equals 24 divided by 12 is 2. Again, works out nicely, right? So let's subtract 10 from both sides, so that x equals 2 minus 10 is negative 8. So negative 8 for that one. On this one here, we have 1/6 times x plus 6 equals 11. And on this one, I'm going to go ahead and distribute because I know 1/6 times a 6 is going to equal 1. So I'm going to distribute here and have 1/6x plus 1 equals 11. I'll subtract, 11. Subtract 1 from both sides, and I have 1/6x equals 10. And I'll multiply by the reciprocal, so that x equals 10 times 6 is 60. All right, so there's that one there. And one final one, we have 5/7 times x minus 9 equals 25. This one here is a little bit different, okay? I'm going to go ahead and multiply by the reciprocal so that, and you think, well, why multiply by the reciprocal? Well, because I know that by putting the 5 over here, I can at least reduce this to 1 and 5 there, which leaves me with x minus 9 equals 35, right? Multiplying that out. Now I add 9, and x equals 44. Again, this is just one way of solving each problem. You could have done the other way, and that would be just fine. Those become your solutions there. All right, number 4. It says select all the expressions that represent a correct solution for this equation. So what we're looking at is what are the different ways we can get a solution for x? Well, we've been talking about 2 different ways of solving it, so let's work that out. We can have the equation, and we could, first of all, we could divide both sides by 6. So we have x plus 4 equals 20 divided by 6. And then I can subtract 4 from both sides, so that x equals 20 divided by 6 minus 4 is basically what I have there. That's one way. The other way is by doing 6 times the quantity x plus 4 equals 20. I could distribute and have 6x plus 24 equals 20. I could subtract 24 from both sides, so that I have 6x equals 20 minus 24. I'm not solving it, I'm just trying to show you how the steps work out. And then I'd either divide both sides by 6 or multiply by the reciprocal. So x would be 20 minus 24 divided by 6, or I could write that as x equals 20 minus 24 times 1/6, or sorry, times 1/6. That's the same as divided by 6. Now let's take a look over here. Here I have 20 minus 4 divided by 6. That's almost like this, but I'm never going to have a spot where I subtract 4 from 20. Just not going to work. I have 20 minus 24 divided by 6, but not 20 minus 4. Doesn't quite work. I don't see that showing up in this one, or this one. Here is 1/6 times 20 minus 4. Well, there's my 1/6, but it should be 20 minus 24, so that doesn't work. Here's 20 minus 6 minus 4, which again doesn't work. There should be divided by 6 somewhere, so no. Here's 20 divided by 6 minus 4, which matches that one exactly. That works. Here is 1/6 times 20 minus 24. Well, that's here. 20 minus 24 times a 6. That works. And here's 20 minus 24 divided by 6, which is that one right there. So by just working them out, you can kind of see where your solutions are going to be there. And that's the idea. Last one here says Lynn and Noah are solving the equation 7 times the quantity x plus 2 equal 91. And I'm guessing they're both going to do it a different way. Yep, there they are. Lynn used the distributive property and Noah divides each side by 7. So how does that work out? Well, I'm going to put it here just so we can see it a little bit bigger. So for Lynn has 7 times x plus 2 equals 91. And Lynn's going to distribute, right? So here we go. 7 times x is 7x. 7 times 2 is plus 14. That still equals 91. Then we're going to subtract 14. That's what Lynn would do next. So it's 7x equals 77. And divide both sides by 7 so that x equals 11. That works great. Now Noah did it a little differently. Noah did 7 times quantity x plus 2 equals 91. Noah divided both sides, right, by 7. And x plus 2 then equals 91 divided by 7. Now this one might look a little funny if you're not sure, but if you were to calculate it out or do it like long division ways, 7 goes into 9 one time. We subtract, bring down the 1, 7 goes into 21, 13, and so we just have the number 13 there. So that's pretty straightforward, really, although I don't know my math facts up to 13s, but it worked out nicely though. So now I would subtract 2, and x equals 11. Do both methods work? Yes, they do. What's the same, what's different? Either way, you're going to have some spot where you're subtracting. Here we're subtracting 14, here we're subtracting 2, and you're going to have a spot where you're dividing. Here we're dividing by 7, and here we're dividing by 7. Now the order's different, isn't it? Different. Here we divided and then subtracted. Here we subtracted and then divided. And so as a result, you end up with a different process, but the same solution. So what's the same about them is the solution's definitely the same, even the methods are different. Hope that helped you out a little bit, and we'll see you next time.